I'm pleased to introduce the speaker for this session, Gene Pache. Gene is the founder, president, and CEO of TempoQuest, where he is responsible for the development, marketing, and distribution of the weather software AceCAST, which is used in accelerating regional weather forecasting models. Before his time at TempoQuest, Gene was founder, president, and COO of GeoMetWatch, where he built, operated, and deployed a 6-satellite constellation of hyperspectral sounders in geostationary orbit. It will now be our pleasure to hear from Gene Pache.
Tonight, tornadoes tearing through Texas and Oklahoma. At least 8 reported twisters in the last 24 hours.
Record high rivers turn small Midwest towns into islands.
Oh my God! Yo!
Tonight, Hurricane Ida slamming into Louisiana as a powerful Cat 4 storm, sending fierce winds of up to 150 miles per hour and surging waters.
Our global weather is increasingly more severe. Weather, climate, and water hazards account for 50% of all disasters, 45% of all reported deaths, and an astounding 74% of all reported economic losses. But what if there was a way to create a faster and far more accurate weather forecast? A way to reduce those losses? A way to see the previously unseen? TempoQuest is leading the way with AceCAST, the fastest and most advanced regional forecasting system in the world today. AceCAST visualizations are at an incredible 1 km versus the current 3 km standard used today. AceCAST provides a level of speed and accuracy that has never been possible in weather forecasting until now. With the AceCAST simple-to-use interface, you can start a forecast in seconds and receive a completed forecast in minutes. See the stunning results instantly through Shift on your browser. Or results can be downloaded and used on TempoQuest's own WSV3 for greater accuracy and results. And coming soon, AceCAST visualization results will be shown in immersive 3D.
Hello, ladies and gentlemen. I have a very interesting presentation for you today. I'm going to be talking about weather forecasting, and I'm going to be telling you how TempoQuest, Rescale, and NVIDIA are working together and making a global impact on weather forecasting. Now, I know those of you in California are rolling your eyes and saying, why do I care about weather forecasting? Because it is always beautiful in California, and I know that. I live there. I know exactly what you're saying, but weather forecasting is very important. And typically, until you have a life-impacting event, you don't get too interested in weather forecasting. But I had a life-impacting event. Let me just tell you about it quickly. I was a single-seat fighter pilot flying off of aircraft carriers in the Mediterranean. In fact, this particular night, we were in the Adriatic Sea. And no sooner did we take off and we encountered a whole line of thunderstorms. And they just went on forever. And they hung around the ship forever. And what happened was we were able to hold above those storms under a bright moon, but unfortunately we had to penetrate through the thunderstorms. St. Elmo's fire, the noise sounded like machine guns going off in the cockpit. It was pretty scary. And finally, when I got down to the ship, I couldn't see the ship because it was raining so hard. So I was diverted to a field called Andraveda, Greece. And just before I landed, the tower came up and said there were 6-inch puddles on the runway. Well, in an A7, that's like landing in a lake. Well, I rolled out and got about halfway down the runway and blew one tire, and then I blew another tire. And then I started a 360-degree turn on the runway. And I thought that was it. Thought I was toast. But luckily, the airplane came to rest 3 feet from the edge of the runway. So I was alive, and I was ecstatic. But I can tell you that changed me, and ever since then I've been very interested in weather forecasting. TempoQuest is a weather software and analytics company. TempoQuest is known for using GPUs, starting with NVIDIA's, to accelerate the most widely used regional weather model called WRF. Oh my God, another roll of the eyes. Very boring. Weather research and forecasting. I will tell you about this shortly. Further, TempoQuest is using Rescale's infrastructure to make weather forecasting incredibly easy. With Rescale, we can do in seconds what would otherwise take hours. Already we complete the fastest, most precise weather forecast with the greatest insight at the lowest cost. Here is my main message for you today. TempoQuest, Rescale, and NVIDIA are revolutionizing and democratizing weather forecasting for the world. We are continually working to improve forecasting using technology, GPUs, cloud infrastructure, AI, ML, and more. Now, why is weather forecasting important? Why are better forecasts necessary? Well, first of all, it is a societal imperative. Governments owe it to their people to produce the best forecasts possible. Better forecasts save lives. Better forecasts provide enough warning so that people can seek safety. Better forecasts help preserve property. And better forecasts for businesses help increase business profits. Bad weather is the number one interrupter of commerce. Allianz is a reinsurance company headquartered in Munich, Germany. Allianz did a study in which they determined that profit lost due to poorly forecasted weather is equal to 3.4% of a country's GDP. In 2021, the GDP of the United States was over $22 trillion. 3.4% of that ends up at $748 billion. Now, Allianz is saying that American business lost $748 billion due to poorly forecasted weather. Even if it was only 10% of that number, it's still too much, and something has to be done about it. I'm going to give you a primer on weather forecasting. There are three elements necessary to do weather forecasting. You need a model, you need compute resources, and you need data. I'm going to summarize each one of these for you. First of all, weather models. It's a complex array of equations and algorithms with multiple coefficients used to represent the thermodynamics of the atmosphere. We need to have this in order to do a forecast. Models create the forecast. Building models is a complex process. It takes governments and hundreds of software programmers to build these models. Now, TQI or TempoQuest, we don't modify the models, but we do accelerate the models. The next thing we need is compute resources. You need supercomputers to run forecasts at a government level. And it's the most critical and persistent problem that impacts weather forecasting today. There's never enough compute resources to do the forecasting that we want to do. The senator from Washington, her name is Marie Cantwell. She is the chairman of the Senate Committee on Commerce, Science, and Transportation. In the next 5 years, NOAA will require 37 times the processing power that it has today for climate modeling, weather prediction, and forecast. Suffice it to say that the computer shortage will continue. The last factor is data. Current weather data initializes the model. The more data you have, the better the forecast is. However, there is one problem. To be able to process all this data, you need more compute resources. And so there's a lot of data that falls on the floor today that we just can't get to. But GPUs will help that. So TempoQuest forecasts require a number of process steps. We do utilize the WRF regional model, weather research and forecasting, and then we accelerate that model with GPUs. GPUs provide a faster, higher precision forecast that provides higher insight at lower cost. Here's my main message for today. TempoQuest, NVIDIA, and Rescale are revolutionizing weather forecasting. We're doing it through faster forecasts at higher precision, providing greater insight at less cost. Now, let me go through each one of these. Faster forecasts. How do we do that? Well, we do it by porting the WRF model to GPUs. GPUs have more arithmetic logic units and can do the forecast faster, and our simulations show this repeatedly. There's a GPU, there's an A100. A lot of you are familiar with that. We use those GPUs to accelerate the weather forecasts. The reason GPUs accelerate weather forecasts is because they have more ALUs, more arithmetic logic units. So they have more calculation capability, and so they can do more calculations in a given period of time, which makes them perfect for weather forecasting. And I've told you that we've done a number of simulations showing that GPUs are actually faster than CPUs. This happens to be a simulation where we compared GPUs to CPUs, and the acceleration factors as high as 16 for one CPU and 8 for another. Suffice to say that the GPUs are faster than CPUs. Higher precision. We're able to get to higher precision because we have a faster forecast, and we're able to get to the 1 kilometer within the time frame that we have to do the forecast. So therefore, we can improve precision anywhere from 9 to 18 times. And greater precision gives us greater insight. Greater insight is possible because we have a higher resolution. 1 kilometer forecasts see more than 3 kilometer forecasts. Now, let me show you some examples of this. An event happened southwest of Chicago on August 9th, 2021. A group of tornadoes formed in the area there. Now, this graphic shows the increased fidelity shown by the 1 kilometer AceCAST forecast. Notice on the right that it's much more precise and much more weather is revealed as a result of the 1 kilometer. Now we're going to another example that represents a measurement called storm relative helicity. This is a number that we measure to determine the likelihood of tornadoes. The higher the storm relative helicity, the greater the chance of tornadoes. Notice that the 1 kilometer representation on the right shows a much higher storm relative helicity than the 3 kilometer. It's as high as 550 versus 275 for the 3 kilometer. Now you're going to see where the tornadoes actually touch down. This graphic shows how the 1 kilometer detected where the tornadoes were going to touch down. The left graphic again, 1 kilometer, shows the weather in this area. The center oval shows no weather. On the right side, you see that the tornadoes actually touch down where the 1 kilometer forecast said they would. Better insight from higher resolution. Last, we want to talk about cost. GPU forecasting is less expensive than CPU forecasting. There are a number of reasons for this. First of all, GPUs require less hardware because they do more work. Secondly, GPUs require less power, so they're cheaper. And GPUs use less storage, less rack, and infrastructure. Though, again, they're cheaper. Generally speaking, GPU forecasting is half of what CPU forecasting costs. Okay, this is a little bit of a complicated slide to look at quickly to see what we want you to see. The y-axis is cost, the x-axis is speed. CPUs are represented by the blue line and the red line. The GPU is represented by the gold line. In summary, lower is better. So in this case, GPUs are lower and further to the right, indicating that they cost less and are faster. CPUs are upper left, which means that they take longer and they're more expensive. This graphic is a 3-year utilization of the same thing. But again, look, CPU wharf is more expensive than GPU wharf, shown on the right, even though you have to include the AceCAST license. So total cost of ownership for a GPU simulation over this period of time is less than CPU. In fact, it's greater than 50% less. In summary, we have proven that we are revolutionizing forecasting by making forecasts faster, making them higher resolution, making so they provide more insight at less cost. Now we're going to talk about democratization of forecasting. What do we mean by that? We mean that we're going to make forecasting available to everybody. And this is a result of a Rescale TempoQuest development. It's a leveraging of the Rescale infrastructure, and it's showcasing Rescale's ability to streamline and accelerate processes. Forecasting is difficult and hard to execute. It requires extensive study and typically a PhD to do weather forecasting. Forecast pre-work can take hours, and initiation of a forecast run can take greater than 60 minutes. It can take you up to 600 command lines to initiate a forecast. Now, this video that I'm showing is a 15-minute video that we've accelerated to less than 1 minute. But what I want you to see is all of the instructions that have to be provided to a computer to do a WRF run. It's tedious and cumbersome and prone to errors in order for you to do a manual run. Keep this in mind because we're going to show you an application that does it very rapidly. Now we're going to show you AceCAST WRF on Demand, or WRF on Demand. It's a software as a service application. It is a TempoQuest user interface. It enables a democratization. It's a combination Rescale TempoQuest development. It leverages the Rescale cloud infrastructure. You can actually start a run in 30 seconds. It's 120 times faster than the manual run I just showed you on that video. This is brilliant work by Rescale. Here's the user interface that was developed by TempoQuest working with Rescale. You'll see that the user interface is divided up into two. On the right side is a map that enables you to choose any location from any location in the world anytime, as long as you have an internet connection. The left side enables you to choose 6 parameters, only 6 compared to that video that I just showed you. And 2 of those 6 are preset. So we choose the model initialization, we choose forecast duration, we choose a forecast interval, and the resolution, and then we confirm the east, west, north, south boundaries of the domain we want to cover. As soon as all that's done, we hit compute.
The first thing we're going to do is choose a location. We slew the map so that the location we want is on the map face. So I slew to the east, and then I want to do Houston. So Houston appears on the map face. Point with my gloved finger, and there it is. Houston selected. Now I go to the left side, and I choose my domain parameters. The model initialization of her, 3-hour duration for the forecast, 30-minute forecast interval, 1 kilometer resolution. I choose my east, west, north, south domain boundaries. And all my parameters are set. I'm ready to go. I hit submit. Now I have initialized the forecast, and in just a moment, a link will appear that we can use to check the data and check the visualization.
Democratizing weather forecasting. That's what we've just done here. That's what we showed you. This is unparalleled simplicity and unparalleled speed. So we now have talked about the ability for us to revolutionize forecasting and the ability of the 3 companies working together to democratize forecasting. Now, just before I finish this presentation, I do want to thank some of the people who were instrumental in us achieving this success. From Rescale, we have Rob Agnew, who's the Enterprise Account Executive. We have Chris Ramirez, who is the Solutions Architect. Kevin Kanjemi is the Strategic Partners Principal. And Jolie Hales, who I've recently met, she's our video producer. She's the one who did the video for all of these presentations. And I want to thank NVIDIA, Stan Posey, who's the Program Manager for Earth Systems, and Jeff Addy, who's a Principal Solutions Architect, for all the support they've given us to ensure that we got the acceleration of WRF using GPUs. So that concludes my presentation. I want to thank everybody for their attention.